All right, now we're going to take some data, maybe more interesting data, and work towards creating an equation of a line. So here is taxifarefinder.com. It's a cab ride from the airport in Las Vegas, and it gives you an initial charge of $5.10 plus $2.60 per mile. So we're going to fill in the rest of this table. Notice that we've done a little bit for us. By the way, mathematicians always write things as X is the first column, Y is the second column. This convention doesn't have to be that way, but it always happens that way. So you can see where we're getting this data. We started at 510, and then after 1 mile, we'd add in that $2.60, add another $2.60, that got us to 1030, add another $2.60, we get 1290, add another $2.60, we get 1550, add it one more time, and we get, what, 1810. So we've completed our table. Then we're asked to draw a graph, and I shudder as I look at this graph. Okay, this is supposed to be the x-axis, this is supposed to be the y-axis, but look at this mess. These are rectangles, not squares. Or I should say non-square rectangles. So the distance from, say, 0 to 1 mile, 2 miles, 3 miles, 4 miles, 5 miles is not spread out the same way it is for the up and down distance. And then creating this scale, like this scale is easy for the miles, right? All we have is 0 to 5, nice whole numbers. But going up the y-axis, good gracious, what are we going to do? Are we going to say 510 and then 1020, or it might be nice to do units of 260, but that beginning value of 510 totally messes that up. So maybe what's best is to go 2, 4, 6, 8, 10, 12. Is that really what we want? 2, 4, 6, 8, 10, 12. It's supposed to be here. 14, 16, 18. Their last line would be 20. Okay, and now we can rough sketch this mess. So 0, 5, 10, I don't know, somewhere in between 4 and 6. 1, 7, 70, somewhere between 6 and 8, we'll call it there. And then 2, 10, 30, and I'm immediately losing interest, right? This is awful. Oh, hey, we've got technology. Let's do it. So let's go to Desmos, and let's do this in Desmos. So I'm going to introduce a nice feature in Desmos. Maybe we've done it already. I can't remember. Click this plus sign, and you can smash in a table. So there's X and Y. So let's put in 0, 1, 2, 3, 4, 5. And then we're going to do our 510, our 770, 1030, 1290. Oops, hit the wrong button. 1550 and 1810. Oh, all we see is 1 point. That's awful. Ooh, watch this. See this little zoom fit button? Shazam. Oh, whoops. Hey, look at my mistake. I put in 1810. That's a quick view of that mistake. I'll try this again. Oh, look at that. There's a perfect graph of these data. So I'm going to encourage you, anytime you see these, hey, plot these points, give it a little thought. Think through how you might create these scales, how someone might make scales to trick you into thinking something looks a certain way. But instead, run to Desmos or some other graphing calculator and graph it. Graph it perfectly. We've got technology. Let's not let it waste. So what do we observe? Well, when you looked at that graph, the data fit a line. And we already knew that. Remember from 2.1, we knew that a linear sequence occurs, happens when there's constant addition. In this case, that was that 260. So we started at 510 and we're adding the exact same amount each time. So we knew that this sequence of numbers represents a line, a perfect line. And now we have a visual of that line of data. So our author gives us a way to type this into the age-old 1990s. Technology, if you're using Excel is a great place to do this. You can do this in Excel if you want. I'm going to skip that. I'm going to show you some stuff with the project of how to use Excel. For now, I think Desmos is going to be your best bet for the work we're doing here in Unit 2. All right, let's look at some garbage graphs. We're going to come back to that cab ride in a minute. So here's a graph of temperatures. And we're asked, what temperature is this thermometer displaying? Well, first off, if you've ever seen these temps, these non-digital versions, what is it, mercury in here? Where the mercury ends is the temperature. So that's like right here-ish. So what is this tick mark? Well, I don't know. What do these tick marks represent? If we zoom way in, you see, let me focus, a really tiny 15, is that right there? And what is that? Is that representing a tick mark here that this is 15 degrees Fahrenheit, and then we might know a conversion factor into Celsius? Yeah, I don't know. The point of this is, no, we don't know it. No labeling. So it's impossible to read because we have no idea what that meant. We've got the same problem here. We can state that this is x comma y, and we know, for instance, that x is negative and y is positive if they're using the standard things for coordinate planes, where positive values go this way and positive y values are going up. But we have no clue. Maybe they switched this all around because they wanted to. So again, question mark, no label. Authors pointing out you need to label these graphs clearly so that people can actually read them. And then you might think back to Unit 1, where we had pie charts and bar graphs that didn't have numbers labeled to them. And you're like, wait a minute, our author didn't follow his own advice. Well, remember that those cases we were helping you practice estimation skills. So there was a purpose in leaving those labels off. But in reality, you should never do that.